All right, you guys, let's wrap up our discussion on logarithmic functions by talking about solving logarithmic equations. So it says that equations that contain logarithms are called logarithmic equations. Care must be taken when solving logarithmic equations algebraically. In the expression log base a of m, remember that a and m are positive and a cannot equal 1. Okay, so when we are solving these logarithmic equations, we have to be sure to check that each apparent solution in the original equation and discard any that are extraneous. Okay, so keep in mind that the domain for a logarithmic function is from 0 to positive infinity. So we're going to have to make sure we always check our solutions to make sure that it doesn't make our arguments negative. Okay, so let's take a look at some examples. All right, let's look at this one. So it says solve log base 3 of 4x minus 7 equals 2. Okay, so the first thing I want you guys to get in the habit of doing is identifying how many logs you have in your problem, because eventually we will get to problems that have more than one. So I just want you guys to get in the habit of that. So this particular problem has 1 log. Okay, if our problem has 1 log, okay, then our best bet is to convert this to an exponential statement. Okay, so if you guys remember, we converted log statements to exponential statements by going around the world. So 3 to the second power equals this argument. Okay, so now it's no longer a log statement. It's just a normal equation that we can solve. So we have 3 to the second power, which is 9, equals 4x minus 7. And we can solve for x. So I'm going to add 7 to both sides. That's going to give me 16 equals 4x. And I'm going to divide by 4. So x equals 4. Okay. Now before I can accept this, okay, anytime I'm solving a logarithmic equation, I have to check my answer. Okay. So I'm going to say log base 3 of 4, I'm going to plug in the answer I have, times 4 minus 7 equals 2. And I'm checking mainly to see that this argument does not give me something that's negative, and it doesn't give me a 0. So 4 times 4 is 16, and 16 minus 7 is 9. So because this is greater than 0, I'm okay. I get to keep my answer. Okay, so that's what we're checking for, to make sure that the argument of our function does not equal 0, and that it does not equal something that's negative. Okay, so we're good. Let's try another one. All right, this problem says solve log base x of 64 equals 2. Okay, so once again, I want you guys to identify how many logs you have. You have 1 log. Okay, so we're going to convert it to an exponential. Okay, so that's going to give me x squared equals 64. Okay, when I converted it, okay, it became quadratic. Okay, so since it's quadratic, I'm going to solve it like I normally would a quadratic equation. So this one, I'm going to square root both sides. So it's going to give me x equals plus or minus the square root of 64 is 8. Okay, so this gives me 2 answers, positive 8 and negative 8. So before I can accept this, okay, I have to check it. So I'm interested into where this positive 8 and negative 8 is going to go. So this time, the variable that we solve for isn't actually the argument, it's the base, okay, of our log. So our base, okay, cannot be negative. So that means that we have to get rid of the negative 8. So our answer is only going to be x equals positive 8, okay? So that's going to be our answer. Cool. All right, let's try one more. All right, so this one says solve e to the 2x equals 5, okay? Now this particular problem is not a logarithmic equation, okay? There's no logs, we see no logs. So this is an exponential. So I know it's an exponential equation because look at where the variable is. The variable is in the exponent or the superscript, Okay, so the only rule that we have so far to solve for a variable that's in the exponent is that rule that we learned earlier. A to the u equals a to the v. Then we can have u equals v, which means that if we have an exponential and the bases are the same on both sides of the equation, we can drop the bases and set their exponents equal to each other. However, when we look at our problem, the base on the left-hand side is e, and the base on the right-hand side is 5. There's no way that we can get those bases to be the same, okay? Now, what we can do, we can use the logarithm to help us out, okay? So what we can actually do is take the natural log of both sides of our equation, okay? Now, the reason why this is going to work, the natural log and e, okay, they are inverses of each other. So the same way if you have x squared equals 6 and you want to undo x to the second power, we take the square root of it. The reason why that works is because the square root and the second power, they are inverses. So when you apply one to the other, they cancel each other out and you're left with x. The same thing is going to happen over here. So when we take the natural log of e, okay, that's going to cancel. It's going to go to 1, which means that our power is going to drop down equals the natural log of 5, okay? So let me show you something really quick before we finish that problem, okay? So one of the properties of log is that natural log of e equals 1. And the reason why that is, remember natural log, okay, is understood to be this, log base e, okay? So you're asking yourself, e raised to what power would give you e? So if we change that to an exponential, it'd be e to the y equals e. Well, the only way you're going to get e is if the exponent is 1, okay? So that is always why natural log of e equals 1, okay? So just a short lesson. All right, so let's go back to our problem. Okay, so now we have 2x equals natural log of 5, and we're solving for x. So I'm going to divide both sides by 2. So x equals the natural log of 5 over 2. Okay. Now, depending on the directions for your problem, you could leave your answer like this. This answer would be considered your exact answer. Okay. It's your exact answer because you haven't rounded, you haven't put into a calculator or anything. So they will say, what is the exact answer? And you would give them this whole thing, natural log of 5 over 2. If they ask for the approximation, okay, that's your clue word that you are going to plug this quantity into the calculator and get a decimal, okay? So when I plug this quantity into the calculator, natural log of 5 over 2, I get this decimal, okay? And typically they will tell you where to round. So I'm just going to round to 4 decimal places. So that's going to give me 0.8047. Okay. So if they asked for the approximation, I would give them the decimal. If they wanted to know the exact answer, I would give them the answer with the log in it. So both of them are correct. Just make sure that you pay attention to the form. Okay. Cool. I hope this helps.